like same simulation,
same simulation and measurement, but report should be good. Question number 3 and 4 also you have to do.
Okay.
And then submit. You have time until Saturday, I think.
I think,
Just go to Moodle and then you can check.
capture for multiple for capture. Where books?
See here. See experimental results here, simulated values, then measured values. So here around these tables. Only page number 8 is enough.
It's a here, right? And only this reported and
yeah.
all of this not.
They are not very important, but submit. This also I want.
No?
This is only the register 1 case, the same register which you
Can't do this
alone. Everyone alone. So you should pay attention during the class.
Before
I tried to explain you with the slide. I hope it. I will upload these slides also. Okay, so that you have an idea.
Thank you.
So in the exam alone, on one bench you will be alone. Okay. So
Doctor, now I entered. You say something about the exam?
It's not the midterm.
no, they don't have it. They're just asking for the final.
There's no midterm. in this
No,
one?
no, no, no.
Just
In
final?
the midterm, there will be no lab. Yes. How is it going? It's good. Okay.
Doctor, you forgot to open the camera and do share screen.
Yeah. I know. Yes. Yes, I will do it again. But okay. So all of you have the free lab. There is hard copy. No, not only the free lab. I needed the result for all the simulations. On page number 8, I needed the result. No. Did you read the email carefully? Yeah, I did. So this and this right same value. But for voltage you have yeah, this one. So they have free labs,
Yes.
but they didn't fill the table.
Yes, they did.
They did the table.
I checked first table.
These are page number 8. I'm sure none of them. Oh, I did it. But yes. And then you also. I'm aware that how did they none of them.
No, no.
And then even they solve question number 3 and 4 also. So right there, yes. In the email yesterday, a long email. Yes, you can do it. Yeah, yes. Okay. Okay, just do it here. And also log in here. Where is the free? 0. No, that was experiment number 1. Now experiment number 2. No, not this. If you show me right now, then it's fine. If I want it. Just do it now. Not only the free lab, but this voltage of What about it? Yeah. I wanted this. Let's table number 8. Table number 8. So from the next time, always wherever you see the simulated results, you should fill it before coming to the lab. Everywhere when you see the simulation, you have to fill that table. If you see this lab sheet, for all the people who are online also, yesterday I wrote in the email that I want these all values, simulation, all the results for voltage, all the simulated values for who are coming in the lab. You came, many of you came with the pre-lab, but I wanted all the simulations to be done before coming to the lab. Okay, yesterday
Put
I
it
tried
in hardware copy or how?
in hardware, in hard copy, printed copy. Okay. So next time, the people who are sitting in Zoom, they will be coming to the lab. So they have to fill for the lab 3 all the simulated, all the simulation they should do it before coming to. You see, this experiment, none of you calculated the voltage. All of you got the values for the current because it was in the pre-lab, but none of you did this this circuit. So you need these simulated values to verify your results when you will perform the experiment here in the lab. Okay. For the next time, do all the simulations before coming to the lab. Okay. So yes, there was some question from the Zoom. So there was some question from Zoom.
Doctor, if we're online, do we also have to have a hard copy?
For the online, you have to do.
Doctor, your voice is not clear.
Of you who are but in the during the you can problem. So this is all do the evaluations for class.
Doctor, unmute yourself.
Yes, I said that from today class, there will be only the hardware experiment for all Zoom people and for all who are coming to the campus. There will be no simulation. I will just verify your simulated results with my readings, but there will be no simulation. Okay. So now I start today's lecture. So today we are performing experiment number 2, which is related to the Kirchhoff's law. Can anyone tell me what is Kirchhoff's law?
Yes.
Yes.
KCL and KVL.
Yes. Kirchhoff current law and Kirchhoff voltage law. So what is Kirchhoff current law? If you have some resistance, if you have some node, so this is a node, for example, A. How I can apply KCL on this node? For example, this current I1 is coming here, I2 is going here. How I can apply KCL on this node?
All the current entering equal all the current
Leaving. Sum of all the current entering. Maybe there is another resistor. Current can come from here also. Then sum of all the currents entering is equals to sum of all the currents leaving. Okay, so if I write for this one, I1 is equals to I2 plus I3, right? So you can make it minus I1 plus I2 plus I3. Okay, in this is entering current, so that's why this is negative. So if I did it first. Okay, so I1 plus I2 is equals to I3. So if you bring it here, so it will be minus I3 plus I1 plus I2 is equals to 0. Clear?
Yes.
Okay. So can anyone tell me what is KVL? I want some response from the Zoom students. What is KVL?
The sum of the voltage equal to 0.
Yes. But the sum of voltages across a closed loop is equal to 0.
Yes, with the signs.
Yes, if there is something like this, and then this is open. Can I apply KVL?
No, because the loop is a close.
There is no current flow here. The path should be complete. Okay. Now you see this is going from negative to positive. This should be minus 4, minus V4. Positive to negative plus V1 plus V2 plus V3 is equal to 0. Okay. So this is KVL. Sum of all the voltages across a closed loop. It's written here also. Around the closed path is 0. Okay. So now can you tell me what kind of connection is this? Series. So what happens in series? If I want you, if I ask you to write the equation for this, how you will write it? R1 plus R2
That
plus
is R1, R, yeah.
plus R4. Okay. Then what kind of connection is this? Parallel.
Parallel.
What happens in parallel? How you write the equation for this circuit?
1 over R1 plus 1 over R2 plus 1 over R3 and etc.
So like this you write, and then you can solve it. So now this is I don't know, for the Zoom people you can see these values, but for the people sitting here I think this is not very clear. So this was the simulation in your lab 2 experiment for current, and then this was for the voltage. So you see that in for the current measurement I connected the multimeter in series. Yes. And for the voltage measurement, I connected the voltmeter in parallel. Okay. So here while you will perform the hardware experiment, you will connect your multimeter same like this. For the current, you will measure in series. For the voltage, you will measure in parallel. Okay, always. One more thing. So can anyone tell me that what is the current value here? If I ask you to measure the current here, what is the current value here? Anyone? Because in your pre-lab, actually I did this, but in your pre-lab, it was not included. So what kind of connection is this? Series, yes. Exactly, this is series. So what happens in series? If you measure current in series, current will remain
And 3 equal.
yes, yes, exactly. So current will remain same for this. But when if it is a parallel connection, current will be different. And in parallel connection, the voltage will be same. Okay. So that's why this reading is same. This is 0.244. This is 0.245. Current value is same because the resistors are connected in series. These are small concepts for you, which will help you in your next studies. So now, all of you have this NILS board in front of you. This one. So this all of you have. Okay. So you see that there is a breadboard connected here. Okay. This is same here. I will show you that how this is connected. So, if you see that there is these two lines, okay, on top. So you should take, you should see that internally this is connected like this. All this is connected together, and you just say it plus because this is red. You will say it plus. This is negative. All of this is connected like this across the row. But if you see these connections, internally they are connected like this. Like this. They are not connected like this. So, okay, if you put a resistor and here there is no connection. There is nothing here. So, if you put a resistor like this, I ask you, if you put a resistor like this, what will happen? If you put a resistor like this, what will happen? This is connected together. It will short. It will be a short circuit. You cannot put a resistor like this. If you want to put a resistor like this, you have to come put resistor here and then here. Now this is not short circuit. Please pay attention here. Because you have to make the circuit. Okay? So you have to connect the resistor like this. Jump from here. Now there is no connection between it. But if you connect a resistor like this, it will be a short circuit. Okay? Now, on the breadboard, just see, this is a series connection, right? All the resistors are connected in series. Yes? So, how you connect resistors in series? Connect resistor here, like this. Then, you see the node is common. This node is common. This node is common. You see now the path is completing like this. Got it? Yes, you got it? So this is a series connection. If I ask you to connect in parallel, how you will do it? So what happens in parallel? This is parallel connection. For example, another. There is one node common between them. Yes. So how you will connect here? You will connect one resistor here. You will connect another resistor here. Is it connected parallel? No. Because you have to make the node common also. You have to take one wire from here, connect it here. Then you have to take another wire, connect it here. Then you have to take another wire. Now this is a parallel. Because you have to connect, because before they were not connected, they were just, I just put them on the breadboard. Now when I connected them with wire, now this is a complete connection. Complete connection. You understand? So this is also a series connection. How? This node is connected together. This is connected together. This is here. Now this path is completing from here. Okay. Can anyone tell me what kind of connection is this?
Series.
Series. How this is series? How this is series? See, one resistor is connected here, and then this is connected together, right? These all lines are connected internally together. So from here you turn another resistor. So this is a series connection. Okay. Now here this is parallel connection. I explained you before. You see, you connected three resistors, and then with wires you connected this node. Because internally this is connected. Now this is a parallel connection. Because I made lines, but internally there are already connections inside. So internally the circuit is like this. Internally it's like this. All is connected. Now there is no discount between our. Got it? Now in your experiment you have today, there is, I draw it from here. There is 5.6K, there is 3.3K, there is 2.2, then there is, this is your circuit for today, right? 5.6K, 2.2K, 3.3K, and 1K. And there is some more look. One more look. Which one? This is your connection for today. This is your circuit for today. Which loop? No. Sorry. Okay. So this is 10 volt. Can you help me to implement on the breadboard this circuit? First of all, so we can take it this one positive, this one negative. Okay? So what should I do? The first thing, how I will connect this 5.6K resistor? Yes, because my height is not so much, so I will connect it like this. 5.6 came here, and 5.6 is connected here with positive. Yes, this is same, right? I will take connected here. Okay. Now, tell me about 2.2K. It's connected with 5.6K. Like this. This is 2.2K. Okay. Now, 3.3K. There is this node is common between these three resistors. So how can I make this node common? Like this. Now this is how much? 3.3K. Right? Now 1K. How I will connect 1K? This is in series. This is series. Parallel with the 3.3. Yes, parallel with 3.3. How parallel? But series with 2.2. Like this. Come here 1K. Right? Now this positive is connected with 5 volts. So actually, if I could do it here, it would be better. Now this is connected to 5 volt. Plus this is 10 volt. Okay. And now where is ground? This is ground with 3.3K here. Here. This is ground. Understand? This is your hardware implementation of same circuit. Okay? It's better if you connect here because Anyway, this is also fine. So, is it clear to all of you? To all
Yes,
the
yes.
Zoom members also, do you understand how we implement our circuit on the breadboard? This is known as breadboard, by the way. Okay. So I will give you the demonstration for today's work. So I expect from all of you. Yes. Yeah. So I expect you to make your circuit yourself. Okay. So on your laptop, this desktop, go to the search and find NI Elvis instrument board. NI Elvis instrument board.
Doctor, to what?
You don't have it in your home. This is only in the labs. NI Elvis, NIELVIS, instrument launcher. NI Elvis instrument launcher. NI Elvis. Yeah, make it. So, please all of you make a group of 3 on each side. So you see, if you want to check the value of the resistance, you have to connect your multimeter like this, and then on this NILS instrument launcher, you connect the multimeter, and then click on ohm, and then you see this resistor is 1 kilo ohm. 0.9915 means it's 1 kilo ohm. This is on my computer. This value. Here. If it's not clear, this is 1 kilo ohm. Okay, 1 kilo. Okay, so this is the way you can check your. This is 1 kilo ohm. I want 5.6%. So this is 2.2. Okay, so if you see closely on computer, please look at the computer. What's your name? So see here. So I connected 5.6 kilo ohm here, same as I showed you on the drawing. Okay, then Then 2.2 is connected in common node with 5.6. Can you see? Can't see you? Here. Then 1 kilo ohm is connected in series with 2.2 kilo ohm. Then 3.3 is connected in common node with. Now I need the wires. What happened? Suddenly, what happened here? Please log in with your. So now where is 5 volt? What is connected with one? Okay. Is connected with the ground. For the 10 volt, we will use the variable power supply. Then I will come here. I will put 10 volt here and then run. Then I will select voltage. Then I can measure my voltage across. So you see, this is 5.8. You also have the same.
Yes.
So you also have this same measurement for 5.6, right? And then for current, you will connect in series, right? How you will connect in series? Just take out this positive, connect it here, take out this, and then take knob. 1.03. This is the same reading as your simulation. So why we are doing the simulation? Because we want to verify with the now here. Is it clear to all the people on Zoom?
Yes, miss.
Okay. So please follow these steps, and because you will be needing these steps for your when you will come to the lab in the next week. Okay.
Sure, miss.
Okay. So
Dr. Yuni, we didn't do anything now.
yes, you have to do.
What?
Okay. Sorry. What? 1 minute. I share my screen. So this is connection, same connection here. So for all the people in Zoom, I want to see your simulated values.
From where we can get this?
You should perform the experiment on multisim. Okay.
Yes, I understand, but the model you upload experiment 2, and from there we can do it to a multisim,
See?
or you will do it with us here.
Okay, I can do with you. Go to the Moodle. Did you download it already? Your experiment number 2?
Yes.
So this is experiment number 2, right?
Yes.
Correct. So this is your circuit for today. This is not for you.
Yes, we did it, doctor.
You did it. Show me your result.
Yes, sure. I can share my screen.
So only run the circuit, miss.
No, it didn't.
Did you measure both voltage and current?
We should do this circuit, that upside in multisim.
Yes.
Right?
Yes.
Okay.
Do it now. All the Zoom members, do it now.
Doctor,
Yes.
can I show you my pre-lab?
Yes. Okay. Yes, Dana. Are you Dana?
No, Sarah, actually. I can share my screen.
Yes. Share your screen.
Doctor, can you see it?
Yes, but I want here also, if I can annotate here, I want the measurement here also. There is 0. I want measurement here also. Whenever you show me any screenshot, I want to see these measurements here. Not only this. Not only this. So please simulate this circuit again and show me your results. Okay? And then Portal window. Are you putting your portal ID? Are you putting your portal ID? Yeah. Portal. Still there. But why? Right. Put your name on new. And remember does not mean that complexity. Make it big and also numbers static capital. Okay, then you should know. But zero for me, so okay, start with your experiment and then execute. Very bad. You should have the results, same results. Come here. Come here. So where is that? Where is that? Current level. This or this? Okay, so 1.0. Minus 5.7. R2 is 4.217. R3 minus. And then perform the experiment with you. These values I already did. Next time, please do all the simulations yourself. I will not do this for you. So how much? 5.7. Because if you don't have these values, how you will know that your experimental results are? How you will know? So R2 is this. How much? 4.27. Then R3 is what? Minus 0.539. And then this one? 0.5. So you got this. تميز across all the
بداية مثلا نقول
so we know how to check
جماعة عندنا ممكن يكون بداية
then select this. This is 1K. This is 2K. This is 1K. 1K. And 1K. Now we need 5. So bring 5 on the table. Please write. Sit here, yes. Do the measurements. Where are the
Doctor,
Yes.
I'm trying to do this circuits on multisum, right? Not this, the another one.
You should have these readings.
Okay, I will do same this in multisum, right?
Okay. Yeah, same.
Okay, in the current measurement, I will put a meter. In the voltage, I will put voltmeter, right?
Yes, exactly.
Okay, thank you.
On this table, there are all the where you are getting this? Yes, this is the point. This I think this Maybe this. You want to make it not fixed Okay. Yes. Now one case. This is 2.2 case. This is 1 But I sent a very long email yesterday. You didn't read it, right? You didn't read the email, right? I sent a very long email yesterday. I don't see it. I didn't receive it.
If I receive it all
Of you. I want from now onward, always I want simulation from your side. I will not do simulation. Just to show you my result, you have to match your result with my simulation. So, how much is current here? 1.03. This is million. Which one? This part of 1.277 minus 0.27. And then tell me voltage come here. Our code is same. Come here. 5.7. 8. Because they also have the same. So you see, now you see that very important that you should have the so they can show that your higher how much is it? Simply that's 1.0. Now I want to show you this current. Okay, so this is R3. So there is current. Okay. First step is now.
Miss Madia.
EE1 شنو؟ هو هذا.
Yes, on Zoom. Someone was calling me.
Yes, I'm Farah. Doctor, can you see this circuit? Is it right or no?
Show me. Show me your. Who was here? Who was speaking? Who was speaking? On Zoom. So I am here to check your result.
Miss, I want to share.
Okay, share with me.
Okay. Is this correct? The result?
No.
Why minus here?
First of all, what is your mistake? You are connecting a voltmeter. You are
All
connecting a
ammeter?
You are measuring the current. How
I
is
think
it
2 voltmeter and 1 ammeter. I don't know what the difference between them
This
actually.
is wrong. This is wrong. Come here. So, ammeter, you have to connect ammeter.
Doctor said something was wrong in the internet. I'll come back.
I was waiting for you.
Yes, something was wrong in the internet and let me out of the Zoom. Can I just do share screen now? Not share screen, I will open the video.
Okay, yes, now you connect. What's your name? Abdul Aziz. Connect
Yes.
it now and then connect all these and then change these voltage values. One is 5, this one is 5 volt, this one is 10 volt.
Okay. Okay.
Okay. Now share me your screen. I can't see. Okay. Yes. 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 This is current. This
Okay,
is
now I do the voltage and where I submit them.
put it on the page number 8. There is a table. You don't have to put the measured values. You just have to put the simulated values and then solve question number 3, 4 and also the pre-lab. And then you will submit it. Okay.
Okay, the
Yes.
pre-lab, the first lab we did, right? The same.
Pre-lab is same. This one you did these.
Okay, question 3 and 4, what?
Question number 3 and 4. Yes. Also.
Yes, what?
What?
No, what I will do in question 3 and 4?
I
And I
show.
have to draw a circuit or what?
So you see, question
Yeah.
for all of you, question number 3 and 4 you have to add in your report. You for the people who are sitting here, they have to verify the KCL equation using the simulated values. And for all of you who are online, you should solve with simulated values, and then who are here, they should solve with measured values. Okay. Okay. And then verify KVL equation for loop 1 and 2. And then question number 4 for the circuit in diagram 2.7. This is diagram.
In the Zoom, which value? Simulated value?
Simulated, yes. In the Zoom simulated for both.
Okay, where can I get these value?
From your simulation.
Okay.
Doctor, so the people on Zoom, we don't fill out the measured values?
These are the voltage values. So from
Okay, I'm sorry for asking a lot of questions, but where is simulated value here in this circuit? Yani all the value?
This is the value of current across R1. This is the value of current across. Can you see my mouse?
Yes, yes.
This is simulated value across R1. This is
R1.
simulated value across R3. This is simulated value of current across
R2.
R2. This is the simulated value of voltage across R1. So like this.
Yes, yes, I understand. Thank you.
Miss?
So we finish now? This?
Now,
Doctor?
yes, all of them? No.
Some, all of them, right?
Where is my mic? Where put my mic?
بداية هذا بداية هذا السيستم والمفروض يبقى 55 بنهاية السيستم.
Take from here.
No, I want how did I take the budget?
Just write.
It's not the same.
لأنه كل خمسة
Yeah, it's the same.
Why is it not the same?
هي صح إنه مربوط واحد بواحد بس إنه بين هذا واحد اللي أيام خمسة فهذا وهذا نظم مختلف. مستخدم معكم هي أو مستخدم هذول بس
That would be
Always you may put this.
right? This is all parallel, right and left of this.
Now this is 10. Okay. One more thing. Come here.
اللي هو هذا اللي فوق الجراوند
5.7. Same value, right? Yeah.
اللي فوق نفس
6.538.
واللي فوق اللي فوق 50 انت تشوف نفسي
0.538.
اللي فوق الجراوند
0.244.
واللي فوق
4.21.
الايفون بلس اللي هي يعني هاي نيجاتيف هذا نيجاتيف هذا جراوند هذا فوق
You know that? That it was.
خمسة عندنا بس عندنا
Source voltage is 10. Source voltage is 10. You know that? Minus 10 plus 5.6 plus 4.7. This should be. Or this should be. Then here. How much across this? 2.2K. This was, I think, R3. So where is our this one? Minus 0.503 I think this is R4 minus 0.226 plus minus so this will be plus how much? 4.7. Just check.
Check this one.
Because check the resistors because I don't know. Maybe I did mistake. This should be
Okay.
0.
That's equal to 0.
Yes.
So we will check about this result.
Yeah. Check with these resistor values because I don't know if it is R4 or R3. I don't know.
Okay.
Check like this.
Check this out of this.
You're with them. And then check with the circuit. Yes. So R1, R2, R3,
So
R4. Yes, there is a voltage. So minus plus minus plus 5.7. So you see plus minus this will be negative. So just check now this will be check the polarity. Polarity is very important. So you see minus 5 point plus minus this is minus because already you have minus. Then R4 minus you got minus yes 0.503 you got minus here yes. Then this is plus 5 this is 5 only not 5.7 and then this is minus because polarity is different. So yes this should be good.
This one زي
This should be good.
بس يعني طلعنا الاشياء اللي طلعناها صح.
بس كذي تجمعيهم لازم ناخذ اي بس يعني لازم هذا الدائرة حصل صفر وهذا صفر.
نيجي الرسم نشوف بدايتها في نهاية بس هي اصلا بيسكلي كلها النقاط عشان ما تكون تمام عندنا 1 كي هو هذا 1 كي مقسوم من 60 لل 22 لا تسحب على هذا مكتوب هذا مو موجود اي نفس الشيء تمام عادي
Then RT. This is million. And then voltage. Voltage. 5.7. How much? And then this R2. 1.17. Why you are laughing? Minus 0.539. And then now for this I will deduct your smart point. Now come here. Now how you will make it?
بس common thing between them not one. common thing between them إذا أنا قاعد أسويها توازن المالتيميتر أوصل أوصل الصورة بنفس الوقت وهذا هو البوزيتيف وهي يقيس البوزيتيف
So where is R2? This one. So they take out. Very perfect. So you take this and like this. Now we use and take take a photo and screenshot of each video and put in your report. Both NI and this board. Is this 5.16? This one. Yes. Correct. Wait, what? But why you want to take headache? Already connected. Already connected. See, it's already connected. I showed you very clearly. This all is connected. If you put here, if you put anywhere, means they are connected together. Why you take this big headache of breaking the leg of why you want to put it here? See, they are already connected internally. They're already internally connected. Why you want to take that? You not break the leg. All one design is connected. Don't have so now then I want a screenshot each
That is the screenshot we pasted in page number 8.
page number 8 for each reading. Yeah, but where is the reading? So yes, this let's see. It's my the first step is 10 volt. So take I need screenshot of this. I need screenshot of this. They should be together in your report. Okay, I connected like this and then reading. Yeah. So you see, there is insulation. No connection. So this is connected here with this. This is on. Here you can supply, very good supply. So this is connected. Now this is 5 volt. I connected 5 volt here. This is ground. I connected ground here. This is variable power supply. I connected positive and then give variable supply. This was already 5, so I didn't need to take any. Right? Now, so I took this connection from here to here. First, there was no connection between. I took this connection with one. I made this connection. There is no connection. So I took the wire device to connect with the power supply. Power supply is here. You have to give it to yourself in this order. 10 and 5. Here is
Okay.
3.3.
Miss Madia.
Yes, you see one needs to four screenshots. This 4 screenshots. So there are 2. Come, So yes, you see. Please write the related values. I put some. Take care of this also and then take screenshots there. Yes. What happened? What happened? What you want? So for the online students, please show me your work. Yes, Dana, please show me your results. You should have these results for current and for voltage. Yeah, write all these readings. Yes, Isra. Yes, Isra.
I can't share my screen for some reason.
Sorry?
I can't share my screen. I don't know why.
Yeah, because my screen is shared. Okay, now share. Yes, 1 minute. Yes, yes, this is correct. How about current? Yes, this is correct. Correct. Yeah, just put these screenshots and then solve question number 3 and 4. Okay. Yes, Tamir. Yes, Tamir.
Doctor, for us, we don't fill in the measured parts, right?
No, no, no. But you should know that how the measurement, because you are coming to the lab.
Okay, the stimulation part, we need to solve it, right? No, it's not in the circuit.
This is correct. Show me the voltage. Yes. Yeah. Come. No, I measured voltage across 5.6. You can measure the voltage across the other resistors. Just connect parallel like I did.
Doctor, can I see my circuits?
Yes. Yes, Tamir, it's correct. I can't see. If the values are same like me, then it's correct.
Yes, the same. And I
Okay,
put it in the page number 9.
Correct.
Okay.
So, 1 minute. Yeah. I come. One minute.
Doctor, the pre-lab also, we should paste it in this experiment. The pre-lab also, what we did last week, we should also paste it in this experiment, the Word document.
Not last week. Last week was lab 1. This is lab 2.
I can't hear you, doctor.
Cross the resistance.
I can't hear you.
My mic is on.
Yes, but you are so far.
Lab you did in the last week. That I will upload. So the last week you did the lab, that was lab 1. Now you are doing the lab 2. So the results from last week you should paste in lab 1, but then the deadline is over. Now you have to work only on lab 2 for this week. Can you do current measurement? Now I want to see like this. How much? 1.14 million. 1.1. Now remember where the system so which one you want to say you know IR? Where is the second? Yes. So I do with this 3.2. Now yes. Yes. And take this how much? 1.4. Do the third. Then next. So make a group of three. Make a group of three. I want all the screenshots for all the position, for all the meetings, and from simulation also. I want everything on your group. Make a group of three. Yes. When you take yes. Nothing. No question. So okay, for all the Zoom members, now the class is over. So on your report, put all this, put these screenshots with correct reading and solve question number 3 and 4 and submit your report. You have time until Saturday. I already posted the Zoom link for you people. Section 1 and 3. Yes, Dana. Share me your screen for question number 3. Yes, Farah.
No, I don't need anything. I forgot to.
Okay. Okay, Dana. Yes. Yes, finish. Finish. No problem. So, yes. Yes. And then for loop 2. Yes. Yes. Perfect. Yes. This and then question number 4 also do it, and then paste your results from the simulation and then submit your report. Also solve the pre-lab. Okay? Okay, Dana? So this is all from today class. So I leave the meeting now. Anyone have any question?
No, thank you.
Okay, then thank you. Bye bye.
After we turn it in PDF format.
And then submit your report in PDF. No word submission, only PDF. Okay.
Doctor, the last one I did submit it as Word. Is that okay? I didn't know.
Sorry?
I submit the first homework for the lab as Word, like not PDF.
It's okay, but now put all the
Yes,
submit
okay.
all PDFs.
Sure, okay, thank you, Doctor.
Miss,
Okay,
also
I finished the meeting. Yes, done.
I have submitted.
So 3 people per group. Okay. Yeah, thank you.
I am online and join here because don't know absent
When?
with my name and I join.
Tell me your name and then. No, I will not make you absent. So I will put present for all of you today. So 3 people per group.
Okay, we take
All the screenshots?
Yes.
Yes.
That's
And there is also a screenshot.
How many? Yes.
For me, I will take a picture.
Yes.
And with the photo, I will submit. Right?
Yes. And then take care that when you are showing me the NILS reading, connection of multimeter, it should be same with your this reading. If it is different, then I will, yeah, because if you are connecting with 5.6 kilo ohm, it should show me the reading for 5.6 kilo ohm.
Yes, when we
Picture, because you have a lot of.
Doctor, we can left.
Yes, you can leave. Okay.
We didn't take a picture.
So done for today. Have
Okay,
a nice
Miss.
Bye bye. Yes.
I have submitted the one for section 5 by mistake. I thought only one link for us, but there was 2.
No, section 1 and 3 is link. Submission link is same.
No, for section 5, there is another link.
For section 5 is also fine.
It's fine, huh? But
all of them I am checking.
Okay, but I'm section 3, but I've submitted for section 5.
Okay, no problem, no problem.
Okay.
Yes, put all the screenshots, everything.